Hello, look what I have. Okay, this is a question for relativists. Relativity, relativists. Those who believe in relativity. If you still believe in a spinning globe after this, there's no hope for you because the reason you believe in it is conditioning, not thought and not truth. Here we have a disc, a circle. This is going to play the role of half a globe cut along the center and played this way. Okay, that's what this is. You have the north, you have the south, and you have arbitrarily chosen latitudes. These blue lines denote latitudes, with the central one being the equator. The axis is completely vertical. Don't get confused into, the tilt of the Earth's axis. It doesn't matter how the Earth's axis tilts. It's an axis. It means things rotate around it. And they rotate around it like this, not at some angle. That's not what an axis is. So these latitudes, apart from having different speeds at which they turn, so at the equator 1,000 miles per hour and at the North Pole 0 miles per hour, in terms of speed, in terms of miles per hour, now, or kilometers. But you see that these lines, these blue lines, which come all of them under the heading of centrifugal. So this is spinning, and everything on the surface, by virtue of being on a spinning surface, would have a centrifugal force pulling them away, pushing them, flinging them. Think of this, centrifugal flings. So anybody on the surface of the Earth would be flung away from the Earth at a 90-degree angle to the axis, not to the surface of the Earth. Okay, so at a 90-degree angle to the axis, no matter where, no matter which latitude you choose, 90-degree angle to the axis. That's the centrifugal direction. So when people in the north think that what's stopping them from being flung away from the Earth due to its spin is gravity or gravitational force, we have a problem for relativity or relativists. And that's this. Gravitational force pulls towards the center of the masseous form. So the form with mass, being the Earth, has a center, and that center is towards which direction gravity pulls. That's the gravitational force pulls towards the center. That's these red lines. Now here's the problem. Can you see what angle the centrifugal force would fling you at? Can you see what angle the gravitational force would pull you towards the center of the Earth at? Can you see the difference? Let me explain it like this. At the equator, the centrifugal force would fling you away vertically from the surface of the Earth, and the gravitational force at the equator would pull you back towards the Earth in a counter vertical fashion, so back towards the surface. So you have centrifugal pulling away, flinging away, and gravity pulling back at the equator. Can you see how this arrow points this way and this arrow points that way? So the red arrow counters the blue arrow. But can you see how that doesn't happen here or here? In fact, it doesn't happen anywhere else. It means if you're standing, because these red dashes denote how you stand on the surface of the earth. This is why people say, oh, those in the south are standing upside down to those in the north. Okay, that's why. That's the angle at which you stand relative to the center of the earth. And that's the angle at which gravity would have to push you towards the earth. That angle, not this angle. And this angle is the angle at which you're flung away from the earth. Do you see? Do you see the difference? Not only is the angle different, so not a counterforce like at the equator, but it gets more acute the further north you go, until you go to the North Pole, where you have no centrifugal force whatsoever, only gravitational. So if here you're, say, 50 kilos, and those 50 kilos are being flung away from the earth, and gravity is pushing with its force on those 50 kilos towards the center of the earth, you see 50 minus 50 equals 0. At the North Pole, you weigh 50 kilos and the gravitational force is pulling you down 50 kilos, but you have no centrifugal force countering that. So it's a bit of a mystery for relativists. So if you can answer this, Globelings, then go ahead and make a video, explain it with a comment. Don't forget to address both points. If you're standing here on the surface of the earth, you would be being flung away southwards. You see, this means south. See, that would be southwards. You would be being flung away on the azimuth at 180 degrees. That's what. And here you'll be being flung down also at 180 degrees on the azimuth, but at a different angle to the surface of the earth, so at a different elevation. This is a problem, Slice Barcane. So thanks for watching. Oh, just in case you want to explain this to anybody else, tell them this axis, let's pretend it's a pencil, and let's pretend that every single latitude is like a compact disc, smaller and smaller and smaller towards the north and full size at the equator. Just a series of discs that you have with a central pencil. Now, if you spin all those discs, they will spin like this, which means if you were to fracture any of those discs, so that that fracture was only just clinging up, maybe by static charge, and you spun those discs playing latitudes, that's the direction in which anything would be flung away according to the centrifugal force. Well, if this is the direction in which things are pulled away and gravity pulls in that way, there's a problem, isn't there? So the next time some globeling says the reason they don't fly off and they jump, tell them they're not supposed to be jumping unless they're at the equator. They should be jumping, leaning, and countering that force. Okay, I hope that was not too complicated or convoluted. Right, thanks for watching. Bye.